Hello, calculus students. Back at it. Looks like we got quite a few more weeks of this, so really dig in. Most of you are doing a nice job, so keep at it. We are going to continue on Standard 5 today. I want to talk to you about something called L'Hopital's rule. So if you look back at the rubric, which you should have already done, it's just at the very bottom of level 3. I actually have never really taught it much before, but NCC wanted it in their curriculum this year, so we need to talk about L'Hopital's rule. It's kind of in a strange place because it deals a lot with derivatives and specifically finding the derivatives of functions in quotient form. So you got a fraction, function on the top, function on the bottom. And so it feels like it probably should have been put somewhere else, but the online book has it coming right after optimization. And so we're going to go with it. I want to show you a few things, clarify a few things, but ultimately you need to read through the section. I can't remember what section it is. Is it 4.8 maybe? Read through that. But even as I was reading through that, as it was starting to explain L'Hopital's rule, I noticed something that looked like this. So again, in the book, they showed this as they started to explain L'Hopital's rule. F of x is approximately equal to f of a plus f prime of a times x minus a. And they mainly just use this to kind of give a proof of L'Hopital's rule. And we're not going to concern ourselves too much with being able to prove L'Hopital's rule and understand all the ins and outs of that. I want you to be able to use L'Hopital's rule, but you don't necessarily have to prove it. But this comes up, and I want to take a moment to explain this a little bit, give you some background on it, because I think it's also going to help us in the next section called Newton's rule or something like that. It's also linear approximation. So this idea we do need to understand, and so I'm going to take time to do that first. Then I'm going to explain to you what L'Hopital's rule is and go through some examples. This video might get a little longer than others, so I apologize ahead of time, but I wanted to at least give some teaching on that. So first of all, what in the world is this? Well, here's what we're going to do. We're going to start with a graph, and we're going to look at a function on that graph, and we're going to call this the function f of x. Okay, I'll try and change up markers here a little bit once in a while. So what we're going to do is we're going to look at a specific point on that graph, and we're going to call that a. That's the x value. So obviously the y value there is f of a. Okay. And then what we're going to do is we're going to take the derivative of f of a, and we know the derivative represents the slope of a tangent line. So is that going to be hard to see? That might be kind of hard to see, sorry. But I do want to have a little bit different colors here. So this line right here, I'll go back. That line right there represents f prime at a, the slope of the tangent line going through a, all right? Now you can see a lot of these things already are showing up in this formula here. The only thing that hasn't shown up yet is an x. So we're going to put an x over here. Normally x would probably be a little closer to a, but we'll separate out so there's plenty of room. And if we go up here, obviously where that line would hit the curve, that would be f of x. But what we're going to do right now is we're going to actually extend that to this, to the tangent line there. And this is going to be approximately f of x. They use this, this idea to approximate a new point on your function. Let's say you didn't actually have this function, but you somehow had the derivative of f at a. You could use this tangent line right here, to approximate where f of x would be at some later point x. Okay, so picture that, and then what we're going to do is I'm going to zoom in right here. Okay, And so obviously I could just zoom in close, but I want you to be able to see it. I want me to be able to see it a little better. So here's our curve. Oh, that was a bad curve. Here's our curve. Here's our tangent line. Okay. This right here we said was A. And then this is f of A. And then over here was our x. And then here was our f of x. Okay, so we just zoomed in. All right, so that's all the zoomed in part. Okay, now what I want to show you here, and this is where I should have had more markers. I want us to look at this tangent line slope here. Okay, I want us to think about rise and run for a moment. All right, so the rise from here to here, how much did we go from there to there? Well, we went from f of a to f of x. So that distance would be f of x minus f of a. Just take the difference in those, the difference in y's, y2 minus y1. What about here? Well, we went from a to x, so we went x minus a distance from there to there. Okay, so now think about this, and I'm running out of room. So if you take these two and put them in our slope formula, we know it was y2, so f of x, minus y1, f of a, over x2 minus x1, right? But we already knew what the slope was there, right? That was our f prime of a, all right? So I'm actually just going to take that out. I'm going to put f prime of a right there. That's our slope. So if we just do some algebraic manipulation here, we'll be able to get it into that form that we were seeing earlier. So I'm going to multiply both sides by that. So I have f prime of a times x minus a equals f of x minus f of a. And then I'm going to just add f of a to both sides. So f of a, come on, f of a plus f prime of a times x minus a equals f of x. Okay, and if you notice, that's exactly what I had written up here to begin with, all except the approximation. Remember, it's not exactly f of x, it's just getting close to it. So I should change this to approximately, all right? But that equation that we just saw is just another form of the slope formula that we're used to. So hopefully that makes that make a little more sense. And we're going to come back to that when we do more linear approximation stuff. That'll be later in the week. So don't forget about this. Keep that in mind. All right. I'm going to do 2 videos. So that's the first one.